limit problem's going wild. Okay, this one actually does factor. And so basically this is what you have seen before, but it's just kind of ramped up a little bit. So let's first of all talk about the fact that if you plugged in a 3, you'd have 0 over 0. So let's not play that game. Then we will start trying to factor, and we can. So let's do. So what we really have is the limit as x approaches 3. Square root of x minus square root of 3. The numerator does factor. It is the difference of two squares, and it would be x plus 3 and x minus 3. So nothing cancels yet, but it's about to. We can factor out even more. So we're going to factor this. This is the difference of two squares. Doesn't look like it, but it is. This is the difference of two squares if we dabble in imaginary numbers. Let's not. So let us proceed by keeping that the way it is. And then x minus 3, this x minus 3, we're going to break it up into the square root of x plus the square root of 3 and the square root of x minus the square root of 3. There we go. They're not perfect squares. We'll make them be perfect squares. And then we draw a perfectly straight line. I tried. And then we'll grab a different color pen and we will cancel out whatever is, well, obvious and ready to cancel, which is the square root of x minus the square root of 3. All right, we are left with the limit as x approaches 3 of x plus 3, square root of x plus the square root of 3, and nothing in the denominator. So then the question is it okay for us to plug in a 3 for x now? Yes, we're not dividing by 0, so we're good. Let's do it. So we now have 3 plus 3 times the square root of 3 plus the square root of 3, square root of 3 plus the square root of 3. We can do this in our head, but I chose to write it out for the sake of explanation. And so the square root of 3 plus the square root of 3 is going to give me not the square root of 6, it gives me 2 square root of 3. So I have 6 times 2 square root of 3, which is going to give me 12 square root of 3, right over there on the far side of the board. And that, my friends, is the answer to the first problem. The second problem, things get tricky. Let's do it. We have the limit as x approaches, is it 0? Yeah, 0. Of 1 minus cosine squared theta. Oops, x. Don't mix up your variables now, Holmes. There we go. Over sine x. Okay. So the first time I attempted this problem, I went crazy on it, and I want to show you what I did. Please don't write this, okay? This is not worth your trouble, and it's going to be just so quick and random thought that I'm just going to put it kind of sideways on the board here. If I had this and I wanted to write it again, I could do limit as x approaches 0 of, let's factor 1 minus cosine squared into 1 plus cosine x, and 1 minus cosine, and all that would be divided by sine x, and I tried that and it got me nowhere, right? So there we go, written tiny, sloppy, sideways. It got me nowhere. Sometimes you try things and it just gets you nowhere, so that's not going to work. I broke it up into 2 separate pieces, like finding this limit and multiplying it by finding that limit, and it still didn't work, using some of the properties of limits, but didn't happen. But then something hit me out of nowhere. Not literally hit me out of nowhere, because then I would be well, assaulted. If I wanted to go old school on you here, I could talk about the Pythagorean identity for trig, the main one, and then we could rearrange a few things, and we would say that sine squared is equal to 1 minus cosine squared, right? So the numerator is 1 minus cosine squared. That is sine squared. So what we really have is the limit as x approaches 0 of sine squared over sine. At this point, sine cancels. I have squared in the numerator and 1 in the denominator, so basically subtract your exponents. I have 2 minus 1. So I really just have the limit as x approaches 0 of sine. Now, by the way, just to back up from the very beginning, plugging in a 0 for x means I have sine of 0, which is 0. I would have been dividing by 0, which is why we had to go through this process anyway. But now, it is totally okay to plug in a 0 for x, because I would say, well, sine of 0 is, well, 0. And the answer is 0, and it works. It's going to work just fine.